Hey, baby.
What's going on, beautiful?
Nothing. I came to see what you were doing, P-Chip.
Well, it's what we are doing, actually. You're just in time.
What do I get to do? I hope use that big tool.
Oh, yes.
Okay.
Yeah. We are going to work on battery cables for the new solar generator.
Have we decided on the name yet?
I wonder if we should let the viewers name it. Ooh, that could be
Yes.
risky, huh?
Maybe. It's a good idea.
Folks, this is, I think, video number 3 in our series on the solar generator. I showed you the old solar generator a while back, the one that's gone away, the one we've gutted. And then I showed you that I was conditioning batteries for the solar generator. That's all done. Now we actually get into the design and building of the new solar generator. So can't wait to show you how this is done, and love for you to come along with us and learn with us as we do this. There's a lot of work to do. It's going to be several videos, but I hope you enjoy it. And that means a lot of work for you.
So come ride the solar generator train with us.
The solar generator train. Like Helios. Like Helios. Ride the sunny chariot from sunup to sundown with us.
That's a good blooper. Feeling me up.
Anyway, so Robert, when you're creating battery cables, particularly for a piece of mobile equipment like this solar generator, you want to make sure that, number one, all of your battery cables are the same length. You don't want a large difference in the length of your battery cables. That can cause the battery bank to perform poorly. I mean, a tiny bit is fine, a couple millimeters, okay, but really you want all of your battery cables to be the same length. Even between the batteries, and then from the batteries to whatever it's going to power up, to make sure that you get proper, even flow from both poles. And then the other thing you want to make sure and do is crimp these. When you're building these battery cables, crimp them and solder them. Now, electricians generally, I mean, they can't take time on a site to ordinarily solder these things. They'll just crimp them really well, and that's okay, particularly for a permanent installation in a home or something like that. But as I said, this solar generator is going to be a very large mobile piece of equipment. It's going to be towed behind the truck. And so, with road vibration, shock, all those kinds of things, you want to make sure that all of your electrical connections are solid and secure. And that means making sure you've torqued everything down properly where it needs to be torqued with a torque wrench. It means making sure that you crimp and solder all of the important connections, because the last thing you want when you're going down the road is for a high voltage wire to become detached, or for resistance to build up in a line because it wasn't made properly and cause a fire. So anyway, we're going to show you how we do this tonight. So hey everybody, this is the configuration that I've decided on for the battery bank and the solar generator. I know it's an odd configuration. It's not something you see every day, but with the size of equipment we've got and the size of the mobile base that this is going to be sitting on, also considering the weight, and that these 8 batteries are going to weigh almost 1,000 pounds on the piece of mobile equipment on the trailer. We thought it would be best to do it this way. This will allow us to make the best use of the space inside the trailer where this equipment will be held. I know it doesn't look like it will, but trust me, we tried every configuration we could think of, and this seems to work out best. So we're going to connect these batteries in series, and it's going to be a really interesting connection. You may never have seen this kind of daisy chain configuration before. I certainly have. This is the first for me. I just thought about it and made it up, and I thought, well, this is as good as any, and it seems to make the best use and weight distribution on the trailer. So here we go. I've decided on red cable first of all, just because when I'm powering up, when I'm tying together these batteries, I want to show where current flow is. And I mean, you can use any battery cable color you like. It's just I like to do red for tying the batteries together in series. I'll use a black cable when I send it to the inverter for the negative side, and red for the positive. There'll be a larger gauge, but I really thought it was best to go this route for tying the battery bank together. Now these are 400 amp batteries, and so run in series, the entire amperage of this system is 400 amps. We're not going to use the full 400 amps at any one time. There will be surges of amperage if we turn on a big motor or something like that. It may draw extra current. But it's really important that you size your wire for the loads that you're going to use. And a 1/0 cable will handle about 150 amps of power out of that 400 amp battery bank. So this is a rubber shielded, what they call a welding cable. It's very flexible. It has thin strands of copper in it, and the size on this is what's known as a 1/0, 1/0, or sometimes depicted as just a single 0. It's fairly large, as you can see, and it's designed to carry some serious current.
Okay, so we already determined the length of our cables, and like E-Chip said, they all need to be exactly the same or as close as possible to the same length. So what we did is we marked here on the workbench the distance that the cables need to be. It's about 10 inches or so. We took into consideration the length of the lug, is that what this is? Mm-hmm. The lug, and marked it and determined, that the length was supposed to be the 10-inch length. The next thing we're going to do is we're going to carefully remove the sheathing from the wire, and then we'll proceed to crimp on and solder and all that other stuff, which I'm not really sure what we're doing then. I just know we have to cut and then remove these things. All right. So we're going to use the vise there to be able to hold the wire down. Then we're going to use that, I don't know what kind of saw that is. Hacksaw to cut the wire, which I'm going to get my chance to do that soon, I hope. Awesome job, E-Chip.
6 more to go. Your turn.
I need to make this tight. Oh, but not too tight, because I don't want to damage the stuff in there, huh? Is that good enough?
It's good enough.
Is it hard to cut this? Oh, I'm already into the... Hey, that was fast.
Go, Robber! Go, Robber!
Fast as you.
Nice long strokes.
Oh, like that?
Yeah.
So going back and forth, is it good like that?
Well, you won't cut as fast.
Why not?
Because you're taking too short a stroke. You're not only using a small section of the blade to do the cutting. If you use the whole length, the whole blade cuts.
Oh, I've always done like that when I've sawed things. I'm not all the way through yet.
You're getting close.
We'll be here until 2020 if I have to cut all of these.
Almost there.
Well, eChip has assigned me the removal of the sheathing, which kind of scares me because I don't want to cut the copper line in two or something like that. But he said that it won't hurt if I just nick it, so I don't know.
Okay, so next what you want to do after you've pulled the sheathing off is you want to twist the end of this wire, because the lugs that come with it, or the lugs that are designed to fit it, are very, very tight fit, and that's on purpose. So you want to make sure that you can twist and sort of cinch these wires down to as small a size as possible before you attempt to shove these lugs on here. And then I think the best way to do it is just sort of twist as we go.
It looks difficult.
They are stubborn.
Well, when I tried to put one on, I bent it a little bit.
Yeah.
Is that a bad thing?
Well, you want to get as many of these little strands of copper in here as you can. I mean,
Well, they were in there, but they were bent, not straight.
you know, they're about to get even more bent and soldered on.
Oh.
So I wouldn't worry about that part of it too much. But you definitely want to get them in there.
I'm gonna try. Is it okay?
Of course. Jump in here anytime. But the other thing I want to show,
Okay.
until you turn off.
No.
The other thing I want to demonstrate is try to get these on as far as you can until they stop. But you'll notice also that I've left a little bit of space there, and that's for heat dissipation. This is one of those points in your battery system that can build up resistance and cause heat. So I've removed a little bit of the sheathing back away from where the lug is going to be. Two reasons. One, when I put the torch on this, I don't want to burn the sheathing close to where I'll be soldering. And then also that heat dissipation. Let a little bit of that heat that builds up because of resistance at these points see a little relief. So, now, I have seen battery cables, particularly among solar folks, they like to put an extra piece of sheathing here, or perhaps a piece of shrink tubing or something like that. And I assume the reason for that is to guard against corrosion. I can't argue with that, but at the same time, I think for us in this application, having this exposed a little bit is probably best for heat dissipation, since this mobile generator might be used in a hot environment as it is. So, I'm also using older batteries, as you know. They tend to be a little persnickety, and they can build up heat and things like that as they're charged. So that's what I'm doing. The other thing I prefer to do is to line up the blade of the lug with the wording on the wiring. And that's so that when it's in place on the batteries, anybody can look down and see what kind of wire we're looking at. They don't have to guess. They can look at a glance. So just to make it easier, in case somebody else looks at this besides me.
Lovelies, this little lug thing, trying to get them on here has been difficult. I decided I wasn't going to do it because I'm afraid. And he told me to stop whining.
But you're crying.
So, what are you doing?
You can crimp these instead.
Okay.
Because
How do I
when a cable comes along, you must crimp it.
crimp it how?
Crimp it good.
You must crimp it.
Hold it. Put the crimper over the lug, not the wire. Okay. And move it back and forth. Get it to close up.
And you just squish it on there?
Yeah, it squishes on there.
Ah.
One would hope. You're about to apply 16,000 pounds of force to this little dude.
How do you know it's 16,000 pounds?
Because I bought this and I know what it's rated for.
Oh. That 50 is just the size of the hole?
Correct. That's the size of the aperture, yeah. what you want to aim for when you're soldering, and I am not the world's greatest solderer. In fact, I'm pretty terrible at it. But a couple things to remember. Always heat the part where you want the solder to go, because solder is actually drawn to heat. It almost seems like it gets sucked into whatever is hot. So, for instance, I want the solder to go into this lug and in between the strands of copper. So instead of heating the copper, I'm going to heat the lug and then run my bit of solder right up along the lip of that lug. The solder literally gets sucked into the lug. A couple things you want to be careful of are, number one, don't get this thing so hot that you can't handle it. This is pretty warm right now just for doing this end. And the other thing is, be careful about discoloring your lugs. If you discolor them too much, that's a sign you're probably overdoing it a little bit. Discoloration of the solder itself also is an indicator that maybe it's gotten too hot. So you want the solder to be, if you can, just as pretty as it was when it was coming off the spool when you look and see it here. So don't overdo it, take it slow, nice low heat, and just feed the solder where you want it to go, and you'll watch it just suck right in.
What is this?
Solder? It's a combination of, it's like a welding material. It's a combination of lead and tin usually. This one has silver in it. And then there's also rosin, which is like a flux, like a cleaner, that's actually built into this. Otherwise you'd have to paste on a little bit of a flux, which is like a cleaner that cleans things, that burns off and cleans things off as it welds.
Like rosin your bow?
You know, I don't know if it's the same rosin,
Or
but Johnny, you better play your fill hard.
or rosin, a bag of rosin for baseball?
It may be the same stuff. I don't know. Anybody out there know? And I'll go ahead and put your solder right there, and you'll see it just literally gets sucked right up.
Well, it's not doing anything.
It's not hot enough yet.
Oh, there it goes! It did it! It did it! It did it! Oh!
Okay, go ahead and feed it.
Okay.
Go ahead. I'll hold this while you do that.
Okay.
Feed it up there. Put it in there. Right there along that lip. Just work along the edge of the lip there and feed it through. And you'll know when it gets full because it'll start to just sort of pile up there along that lip. Folks, this is what Robert did. She did a pretty good job.
Except I didn't do it all by myself, but that's okay.
As you can see, the solder just sort of fills that space between the strands of copper and fills up inside of that lug. And that's what you're aiming for right there. You want good coverage inside there. She did a really good job on that one. Folks, thanks for joining us again today. We really appreciate your viewership.
So be sure to subscribe, like, and share, and click the notification button, the little bell over there, so you can get updated when we put out new videos, so you won't miss any of our fun, exciting stuff.
Thanks so much for watching. Take care.